for each and everything in this Linux, there is a framework. Okay, so now what is this framework? So we may also call it as a subsystem or something like this. So what exactly is this framework? So let's understand it like this. So I'm going to basically show you the diagram over here. So why do we really require the framework? So if you see at the hardware level, what we have got, at the hardware level, what we have got is, give me a sec, guys. If you ask me, now what happens is, let's look into the hardware space. So hardware space, what we have got is, we have basically got the controller. Now when you look into the controller, this controller can be from the TI, can be from the Freescale, can be from the NVIDIA. Now on this particular controller, you basically get two lines out, which is basically SDA and SCL. Okay, and on this particular bus you might have the various slave devices. You might have the RTC, you might have the E square prom, you might have the codec or something like that. So this is basically a multi-drop bus, and these all drivers will be these all devices will be there on the bus. So all it depends on what your board has. So now, as you understand, what we need to have is, like in kernel space, whenever we are writing a piece of code, we basically call it as a driver. So what do I require over here is, I basically require a driver for this particular controller. So in the kernel space, I will basically write a driver, I2C controller driver, where you are going to write into the hardware registers of this particular controller. That means they will be memory mapped registers, and you are going to write into those registers. So now this particular driver which you are going to write is going to be SOC dependent. It's going to be SOC dependent. That means if it is from the TI, it will be very specific to the TI. If it is basically coming from the NVIDIA, it is going to be, this driver is going to be very specific to the NVIDIA. So what you need to do is, basically you need to look into the data sheet, and accordingly you need to program the register. So what I mean to say over here is, let me show you. So for instance, if you see, if you see over here, this is my technical reference manual of TI. So now in TI, what happens is, if I go to this guy I2C, there will be the registers. Now these registers are specific to AM335X. If you are going to take any other controller, these particular registers are not going to map, going to be are not available. So I2C slave address, then you will have something like I2C count register, data register, configuration register, something like this. So you are going to write into this registers in order to, so for instance, when you will write into the configuration register, so you have the start condition, stop condition, and all those kind of stuff. So this is very, very specific to the TI. So that's what I mean over here, that whatever driver you are going to write over here is going to be specific to the TI. Okay. So now, so this is going to be specific to the TI. Now, what about the driver for these guys? Driver for these guys. So of course you need the driver for these guys, because what you will be having is, you will be having the RTC data sheet, and what you will be doing is, will be looking into the RTC data sheet, and you will be figuring out, if I basically want to read the time from the RTC, which register should I read, which command should I send. So all those kind of things are going to come from the data sheet. So what you are going to write is, you are going to write a driver for this RTC, E square prom, and codec. Now, as you understand, I have written the driver, but in order to send the data from here to here, I also need to write into these registers, but these guys are not responsible for writing into the hardware registers. Why? Because if I basically also put the hardware register related details over here, that means for every controller in the world, I will have to duplicate this particular driver, which is not the thing which we want. So what we do is, here we just handle the things which should be enough to send some commands to the RTC given the I2C bus. So what we are going to, so now you see this particular driver needs the help from this guy. Okay, it needs the help from this. So one of the thing which we can do is something like this. So let's say this is my controller driver. Okay, this is my controller driver. And this guy is providing the API TI send, for instance, TI send. Now this is my RTC driver. This is my RTC driver. So now this guy will invoke TI send. So this will work fine. You will just invoke TI send. This guy is exposing the APIs. So you will be basically invoking that API and you will be able to send something to your slave device. So that sounds perfectly well. But now with this approach, there is a problem. Let's say tomorrow you are having a controller from NVIDIA and this guy is offering you NV underscore send. So that means you will have to again modify this driver to not use TI underscore send, instead use NV underscore send. But this kind of thing, if we keep on doing, we will have a thousands of copies of this RTC driver. That means this direct coupling which we have got, this direct coupling which we have got, we have to avoid it. And that's where we basically need the framework. Okay, so now what do I mean by framework? So framework means something like this. I have the RTC driver and then I have a controller driver, and in between there will be I2C core, and this controller will register its API with this core. And similarly, what this RTC driver will do is it will invoke the APIs which are given, the generic APIs. So let's say it is offering you the API called I2C transfer, which is generic in nature. So this guy will just invoke those generic APIs. So with that, what will happen is no matter what controller you have, whether you have it from the TI, whether you have it from the NVIDIA, whether you have it from the IMX, it doesn't really matter. So this guy, RTC driver, will always invoke a generic call. So that is the benefit of having framework. So now with this, what happens is your RTC driver, E square prompt driver, codec driver will just interact with the framework, and it is the framework which is going to invoke the corresponding controller specific call. So with this, what happens is you have written a RTC driver independent of the controller driver. Now, in I2C terminology, in the I2C Linux I2C framework, this RTC driver, E square prompt driver, codec driver, we call them as a client drivers. Client drivers. And this thing we call it as a adapter. I2C adapter. And this one we call it as a I2C core. So this is the importance of having a framework, and that's where I realized the benefit of having a framework. So until now I was just cursing this stuff, like why it is designed in this way, why it is happening like this, why I'm not able to do. But once I deep dive into this, I highly appreciated the design philosophy. So it is meant for code reusability, so that your drivers, whatever RTC driver and client drivers you are writing, they are independent of the framework. So this same driver, if I run it on the x86 platform, will work as is. The same driver, if I take it on the IMX, will work without any changes. So that is the advantage of having a framework. So Hope you guys are able to realize the importance of having a framework in Linux kernel.